Good morning, everyone. After Friday's work period for your assignment, we're going to do our final lesson in statistics, which is interpreting statistics in the media. So a little bit of a preamble here. In our information chart society, we are bombarded by statistics in news media. Statistics should rarely be taken at face value. Okay. It can be very easy to manipulate statistics to make something appear true that really isn't. Okay, so part of today's lesson is going to be looking at how you can play with statistics a little bit to make it seem like something is true when it isn't necessarily true. Okay, so before that, some quick definitions. The first one is descriptive statistics. So those are statistics that are used to summarize or describe the characteristics of known data. So all that's really saying is if I did a study of some kind, let's say I surveyed 100 people on what kind of pet they have, and I found that 70 of them owned a cat. Okay, then a descriptive statistic is just, out of 100 people surveyed, 70 own a cat. So just literally, this was my sample size, and this is what I found in that sample. Okay, inferential statistics are when you treat data as a sample and use the data to draw conclusions about a larger population. So the only difference between these two is in inferential statistics, I take that information and turn that into, so that means 70% of all people own a cat, because based on my survey, that's what happened in my survey. Okay, so again, descriptive is just more the literal, this is what I had. Inferential is saying, okay, here's the information, therefore, I can infer that the whole population behaves the same way. So what we're going to do now, the next few slides, I have some graphs, and you don't have to copy down the graphs, but you might want to make some notes about what's wrong with them or what's the potential issue with what's going on here. Okay, so here's the first one that I grabbed from Sportsnet. So we've got a nice little comparison of the speed of our R.A. Dickey's knuckleball. So on the one day, or last year, it was, not last year, in 2012, it was 77.3 miles per hour, and oh my goodness, it's down to 75.3 miles per hour in 2013. Okay, and again, hopefully you're looking at that and saying, hold on a sec. Right, the way this bar graph is set up, it looks like this speed is double this one, right? Because of how they set up the scale. I have this huge gap here. Okay, but in reality, it's only a difference. 77 minus 75, that's a difference of 2 miles per hour. Okay, so this is one of the ways that it's really easy to manipulate a graph when you're showing off statistics, is essentially this has a bad scale, right? If this is 2, then these bars should probably go like right off the bottom of the page. And if I saw those side by side with the entire length, I might not be too worried about a 2 mile per hour drop in speed. Okay, so again, bar graphs, okay, pie charts and things, it's easy to play with this a bit. So a similar example of that, and I actually got in a little bit of trouble for this. Okay, you can't see, it's not super clear here, but this graph right here, I'll see if I can zoom that in. Okay, this is the bar graph on the back of a package of Quaker oatmeal from, I think it was the late 80s, somewhere in there. And again, you can't see the numbers too well, but you can see the very clear drop in the bar graphs. But again, the top of this scale is somewhere in the low 200s, and the bottom of this scale is like 196. So again, it's showing this really, really dramatic drop in your cholesterol level, when actually it's going down a little bit each time as you continue to eat Quaker oats. So, right, an easy way to make a deceptive little graph that seems to make something seem a lot better than it actually is. It's still beneficial. Okay, it is, right? The cholesterol was dropping, just not nearly as dramatically as the bar graph shows. Okay, and again, similar issue, it all has to do with messing up scales. This is a graph taken from a British newspaper during an election year with the big headline, "The Liberal Democrats Overtake Labour." Now you can see here, Labor has 24%, Liberal Democrats have 28%, and Conservatives have 38%. But when I look over here, well, okay, same thing. This is 4% here, and this is 10%, right? So, I mean, I think the intention here is to say, hey, look, Liberal Democrats overtake Labor, they pass them, and look how close they are. They're going to catch those Conservatives really quickly. But actually, this gap is a lot bigger. Okay? So again, they've kind of ignored scale, and that makes the bar graph tell a slightly different story than it would otherwise. Okay, so now an actual example that you can kind of write down. But again, you might, from the previous examples, you might want to jot down that manipulating scales is an easy way to make graphs a bit deceptive there. Okay, so this is a typical, right? Television ad states that 4 to 5 dentists prefer some brand of toothpaste. Write a few questions that could be asked about how the study was conducted. Okay, so I invite you as a class to take a couple minutes to brainstorm some possible things you might want to ask about this stat. Again, I have some down here. If you come up with some better ones, please make that part of your notes as well. Okay, so if you're taking a bit of that brainstorming time, here are some things that a previous class came up with. Okay, first thing was when they say the word prefer, right, what does that mean? Right, prefers to what, right? So it would be nice if we could see the actual question, right, that they asked or how they conducted this, right? Did they actually lay out 7 brands of toothpaste and ask which one they prefer? Did they only give them 2 options, one of which was a really bad one? What do they say? Do you prefer using this toothpaste to not brushing at all? Right? What were they actually getting at there? Okay, how many were surveyed? Right? Is this descriptive? Is this literally 4 out of 5 people were asked? Or is this trying to be inferential and saying that, well, we surveyed 1,000 dentists and 800 of them preferred this one, right? So knowing the sample size would be really useful here. Okay. What did the 5th dentist actually say, right? Like, did he not prefer it? Was he neutral? Like, what is the 5th result there? Okay, again, how broad was the sample? So was this like, dentists all in the same city? Was it dentists all over the world? Right, like how widespread was it? Okay, and finally, who conducted it, right? Was it this toothpaste X company that ran it, or was it somebody else? Again, you may come up with some other questions, which I would love to see tomorrow. But yeah, there's lots of different things there. Oh, getting ahead of myself here. Okay, the newspaper poll has an estimated margin of error of plus or minus 3 percentage points, 19 times out of 20. What is meant by that statement? Okay, so again, if you've read some polls or talked about it in other classes, you've probably seen this statement before. Okay, so first, the 19 times out of 20, okay, that's 95%, okay, which hopefully will be a bit familiar to you, right? That's the second marker on the normal distribution. So 95% is 2 standard deviations. Okay. So this number here, realistically, is our standard deviation, which makes it 2 deviations. So I guess, no, this isn't the deviation. 1.5 would be the deviation. Okay, so again, what the statement, again, saying there is that 95% of the time, okay, the survey results would agree within plus or minus 3%. So if a pollster went out and kept asking the same poll question over and over again, 95% of the time, you would expect this to agree or be really close. So if the first time, again, if 70% of people said they owned a cat, the next time you asked, you would expect that between 67 and 73 would say that, and that would reflect if that's actually what's going on. Okay. And then one time out of the 20, it would be different. Okay, it would be more than 3% off. Might not be wildly different, but it would be different. Okay, this is an important thing to keep track of. I think next year for the province, we're going into election year. So if you're watching polls coming up about what percent this party has, what percent this party has. Okay, if they release a new poll and it's within the margin of error, okay, right? If last week, I don't know, for example, we'll say the Liberals, if they had 37% support, and the next week a poll came out and said they had 40% support, if this is the margin of error, then really there's no change. Okay, it sounds like there would be, but if it's within the margin of error, then there's not necessarily any change there. Okay, again, I'll put up some more graphs here. Okay, Fox News, okay, is notorious for putting up graphs that are somewhat deceptive, to the point of which they've actually been called on it and forced to apologize to people from time to time. Okay, so we'll go through a few of them. Okay, so again, it's mostly about scale, right? So here's a graph that shows trying to compare what's going on with the cost of gas, and they have last year, last week, and current. Okay, so again, this is a scale problem, unless this happened to be like on January 7th. Okay, this is representing up to a year, this first point, but the second point represents a week. Okay, like this is not to scale at all. Okay, potentially the slope of this line is actually the same the whole way across if I actually stretch this out to a full year. So again, they've compressed the time scale, and so that might be making that look different than it should be. Okay, this is an interesting one. Right, poverty in America, poorest fifth, now 17% richer. So again, I'm going off the analysis we did last year because I have to make a video here. So some things we looked at the first differences, right? So from 1967 to 1980, in a span of 13 years, right, it went up $1,700. But then in a 30-year gap, it only went up $1,161. Right? And some comments were made, well, it seems odd that this is exactly 20,000 when these other two are not. Okay, they did adjust for inflation, which is good, okay, that it's adjusted. Again, what's the point of this graphic, right? It's trying to say, I would say that it's implying that, well, don't worry about the poorest fifth of the country. Like, look, they're going up. They're 17% richer than they were before. Why would you worry about that? Okay, but if we look again at the time scales, right, the amount of money it's increasing, okay, is lower, right? It's not going as fast. Okay, it gained way more money in a short span in the past than it did in the past 30 years. So yes, they're making more money, but it's not going up at the right rate. Okay, and again, if this is 30 years, as a rough estimate, that would be like about 0.5% per year. Okay, and the rate of inflation is higher than that. So you're still not doing well. Okay, but again, they're trying to make it sound like, it's okay. Okay, in this process of just, why did they pick these three numbers, 67, 80, and 2010, right? Like, why these three and not show a whole bunch more data? So this is a phenomenon we call cherry picking, right? Trying to just pick the best data that will work for the situation. Okay. Did scientists falsify research to support their own theories on global warming? Okay. And I've already given it away here, but if you do the math, okay, this adds up to 120%. So clearly there is some problem with this poll. Not really sure what. Okay. Okay, but again, because it's so bizarre, right? Who was asked? How was it asked? Like, they have multiple options. Like, how do they come up with this? Okay, and it seems interesting that they've ranked these, from the highest percent to the lowest percent, as opposed to just saying very likely, somewhat likely, not very likely, which would show more of a normal trend there. Okay, and again, here's another gas price one. Okay, they have a date picked, so that's Inauguration Day, I think, for President Obama. I don't know when today is. Okay, but again, just taken out of context, okay, you don't really know what the trend is. Okay, And another thing, I mean, obviously, the point of this graph is to try to say, hey, President Obama, how come gas has gone up so much? Okay. But that implies that the president somehow has direct control over gas prices, and he really doesn't. So, I don't know. It's a stat that, it's not necessarily a wrong stat. It may be meaningless in this context. What does that actually say about what's going on? Okay. All right, so that was a whole bunch of stuff at once in a compressed time span there. Okay, here's some practice, to talk about interpreting statistics. Okay, or for fun, you might want to go online, and if you'd like to see more interesting graphs, you can probably type Fox News bad graph, and you can come up with all kinds of interesting things that are there. All right, so thanks for watching, and I will see you tomorrow.